Subject is computer architecture and organization. This is the unit number first, basic computer organization and design. This is lecture number second. Myself Maneesh Singhal, assistant professor, Department of Computer Science and Information Technology, Arya College of Engineering and Information Technology. What is the content? Instruction codes, computer registers, computer instructions, timing and control, instruction cycle, memory reference instructions, input output and interrupt, complete computer description, design of basic computer, design of accumulator logic. Introduction. Every different processor has its own design. It means different registers, buses, micro operations, machine instruction, etc. Modern processor is a very complex device. It contains many registers, multiple arithmetic units, comma, for both integer and floating point calculation. Third, the ability to pipeline several consecutive instructions to speed execution, etc. However, to understand how processor work, use a simplified processor model. Instructions. What is a program? A sequence of machine instruction. Second, machine instruction, a group of bits that tell the computer to perform a specific operation. It means a sequence of micro operation. Micro operation means elementary operation. Third, the instruction of a program along with any needed data are stored in memory. The CPU reads the next instruction from memory. It is placed in an instruction register. It means IR. Last, control circuitry is in control unit, then translate the instruction into the sequence of micro operation necessary to implement it. What is instruction format? A computer instruction is often divided into two parts. First, opcode that specify the operation for that instruction. Second, the address that specifies the register and location in memory to use for that operation. In the basic computer, since the memory contains 4096 words, we needed 12 bits to specify which memory address this instruction will use. In the basic computer, bits 15 of the instruction specify the address mode. Since the memory words and hence the instruction are 16-bit long, that leaves 3 bits for the instructions opcode. This is the instruction format diagram, and there are 16-bit. There are 3 parameters: instruction mode, opcode and address. Processor register. A processor has many registers to hold instruction, address and data, etc. The processor has a register, the program counter PC, that hold the memory address of the next instruction. In a direct or indirect addressing, the processor needs to keep track what location in memory it is addressing. It means the address register AR is used for this. When an operand is found using either direct or indirect addressing, it is placed in the data register DR. The processor then uses this value as data for its operation. The basic computer has a single general purpose register. It means that this is the accumulator. It is temporary register. The processor register. The significance of a general purpose register is that it can be used for loading operand and storing result. For example, load AC with the content of a specific memory location. Store the content of AC into the specified memory location. Often a processor will needs a scratch register to store intermediate result for the other temporary data. In the basic computer, this is a temporary register TR. The basic computer use a very simple model of input-output operation. Input device are considered to send 8 bit of character data to the processor. The processor can send 8 bit of character data to output device. The input register INPR holds an 8 bit character gotten from an input device. The output register OUTR holds an 8-bit character to be sent to an output device. This is the basic computer register: PC, AR, IR, TR, input register, output register, DR, accumulator. This is the table of list of register: DR 16-bit data register, AR 12-bit address register, accumulator 16 bits, IR instruction register 16 bits, holds instruction code, PC 12 bits, program counter, hold address of instruction, TR 16 bits, temporary register, hold temporary data, INPR, it means input register 8 bit, hold input character, OUTR 8 bit, output register, hold output character. Common bus system: the register in the basic computer are connected using a bus. This gives a saving in circuitry over complete connection between registers. This is the diagram of common bus system. There are memory unit, address register, program counter, DR, accumulator, input register, output register, instruction register, temporary register. They are connected through the 16-bit common bus. Basic computer instruction: the basic computer instruction format: memory reference instruction, register reference instruction, input output instruction. Basic computer instruction are the AND, add, LDA, STA, BUN, BSA, ISZ. It means increment and skip if 0. There are CLA, CLE, CMA, CME, CIR, CIL, INC, SPA, SNA, SZA, SZE, HLT. It means halt computer. They are INP, input character to computer, to accumulator, OUT, output character from AC, accumulator, SKI, SKO, ION, interrupt on, IOF, interrupt off. Instruction set completeness: set of instructions using which user can construct machine language program to evaluate any computable function. Instruction type: instruction functional instruction are arithmetic, logic and shift instruction. It means add, CMA, INC, CIR, CIL, and CLA. Transfer instruction means data transfer between the main memory and address and the processor register. For example, LDA, STA. Control instruction: it means program sequencing and control. For example, BUN, BSA, ISZ. Input output instruction: it means input and output. For example, INP, OUT. Control unit: control unit means CU for a processor translate from machine instruction to control signal. It means for the micro operation that implement them. Control unit are implemented in one of two way: first, hardware control unit; second, microprogram control unit. Hardwire control unit means CU is made up of sequential and combinational circuit to generate the control signal. Microprogram control unit: a control memory on the processor contains microprogram that activate the necessary control signal. We will consider a hardwire control implementation of the control unit for the basic computer. This is the timing and control diagram. There are combinational control logic. There are 3 into 8 decoder. There are instruction register. There are 4 into 16 decoder. There are 4-bit sequence counter. It means SC. There are 3 input buses: increment, INR, clear and clock. There are control signal. There are other input. This is the timing signal generated by 4-bit sequence counter and 4 into 16 decoder. The SC can be increment or cleared. For example, T0, T1, T2, T3, T4, T0 and T1. There are different time clock. Assume at time T4, sequencer control is cleared to 0 if decoder output D3 is activate. It means there are different clock cycle, there are different signals are generated. Instruction cycle. In the basic computer, machine instruction is executed in the following cycle: fetch an instruction from memory, decode the instruction and calculate effective address EA, read the EA from memory. If the instruction has an address indirect address, it means fetch operand, execute the instruction. This is the fourth number. After an instruction is executed, the cycle start again at step first for the next instruction. Memory reference instruction. This is the table. There are symbol, operation decoder, symbol description. For example, AND D0, it means accumulator and memory address register. There are AND operation and tends to accumulator. The effective address of the instruction is in AR was placed there during timing signal T2 when I is equal to 0, or during timing signal T3 when I is equal to 1. Memory cycle is assumed to be short enough to complete in a CPU cycle. The execution of MR instruction start with T4. Input, output and interrupt. A terminal with a keyboard and a printer. Input output configuration. There are keyboard, transmitted interface, input register, accumulator, output register, receiver interface, it means serial communication interface, and last input output terminal, it means printer. INPR, it means input output register 8-bit, OUTR output register 8-bit, FGI input flag 1-bit, FGO output flag 1-bit, IN interrupt enable 1-bit. The terminal send and receiver serial information. The serial information from the keyboard is shifted into INPR. The serial information for the printer to store in the output R. Input R, output R communicate with the terminal serially and with the accumulator in parallel. The flags are needed to synchronize the timing difference between input output device and the computer. This is the input output instruction. There are input output SKI, SKO, I on, I off. It means clear AC, input character to AC, output character from AC, skip on input flag, skip on output flag, interrupt enable on, interrupt enable off. Interrupt initiate input output. Open communication only when some data has to be passed. Interrupt. The input output interface instead of the CPU monitors the input output device. When the interface found that the input output device is ready for data transfer, if generates an interrupt request to the CPU. Upon detecting an interrupt, the CPU stop momentarily the task it is doing, branches to the service routine to process the data transfer and then return to the task it was performing. IEN, it means interrupt enable flip-flop. Can be set and clear by the instruction when clearly the computer cannot be interrupted. Complete computer description. There are table, fetch, decode, indirect, interrupt, memory reference, add, end, LDA, HTA, BUN, BSA, ISZ. Register reference CLA, CLE, CMA, CME, CIR, CIL, INC, SPA, SNA, SZA, SZEH, LT. Input output, input output SKI, SKO, I on, I off. Design of basic computer. Hardware component of BC: a memory unit 4096 into 16, register AR, PC, DR, AC, IR, TR, OUTR, INPR, SC, flip-flop, decoder, common bus 16-bit, control logic gates, adder and logic circuit connected to accumulator. There are control logic gates. Number one, input control of the 9 register, read and write control of memory, set, clear and complete, uh, com complement control of the flip flops. There are selection line S0, S1, S2 control the select register for the bus. And last, there are accumulator and adder and logic circuit. This is the control of common bus. There are encoder, there are multiplexer, bus select input. This is the table. There are different selection bus, select register, for example AR, PC, DR, accumulator, IR, TR and memory. Design of accumulator logic. There are adder and logic circuit, there are accumulator, there are control gates, there are 16-bit bus, LD, INR, CLR and there are clock. All the statement of the change the content of accumulator. This is the table. There are AND with DR, add with DR, transfer from DR, transfer from INPR, complement, shift right, shift left, clear, increment. Thank you.